this course is about technology-aware, structured design methodology. And I want to tell you some more what we mean with this. What do we mean with a structured design methodology? And for that, I want to tell you something about an educational method and a way in educational methods we use to describe the levels of students. And here you see a graph with some lines in there. And here you see grades that you can achieve for this course. And the different graphs mean something. For example, this is the lowest level that you can do as a student, and that is remember things. Then the next level is understanding things. So you remember something about that loop gain has a certain definition and you understand what it means. And then the third level is that you can apply this. So you can use it to do a calculation for a circuit. And then you have the levels 4, 5, and 6. And these are the important levels for you. And that is analyze. So this means you did a design. You can analyze the results and get the proper data about what you designed. Then the higher level is evaluate what you have seen. So how come that I have these results? What is the cause for it? Or what is the reason that I cannot achieve my results? So you really understand what you have been measuring. And then the highest level is synthesis, that based on what you have done, the analysis, the evaluation, you actually come with a new circuit. Another circuit, you do an invention or something like that. And that is typically something what engineers do. And if you look at the grades you can get for this course, then you see that if you just remember things, you will not pass the course. If you only understand what things are, then you also will not pass the course. But when you are able to start applying it, you come into the sufficient range. But the really good grades come when you are able to analyze something, and when evaluation and synthesis go okay, then you could even achieve the grade 10 of this course. And of course, here in this place over here with the higher grades, there we have to put the word design methodology, the structured way of coming to the synthesis of a circuit. And how is this done traditionally at the university, and what is the difference of our course? Well, in a traditional course you have students going around in circles like this. So we have active education over here. So we learn students how to remember things, understand things, apply things, and do analysis. And we let you run around in the circle. So, and every time you analyze something, you say, hey, I see this all the time, I see this the same, I see structure or something like that. And gradually you build up your own evaluation skills. And then finally, if you've done enough evaluations, you start building circuits. And then by repetition of designs, repetition of making assignments and analyzing the results, tweaking designs to meet specifications, you gradually develop a personal design methodology. And that is usually the way it works in electronics. They always say, well, if you have a lot of experience and you've seen a lot of circuits, then gradually you know how to do it. And the difficult thing is, of course, tell others how you did it, apart from I built a lot of electronic circuits. You spent a lot of time there, but you cannot actually give the structured way of doing it. And that's very uncomfortable. It takes a lot of time. So repeating designs, analyzing results, and tweaking it until it works gives you experience, but it takes far too much time. So that's what we do not want to do. And that's what we do not want to teach you. And also, it might even give that you cannot do an invention, so really come to something new. And I have an example of that for you. So here you have two radios of about the same time. And if you look at those radios, then I can tell you the radio on the left is a bit older than on the right, because this is a vacuum tube radio on the left, and on the right you see a transistor radio. And now let's have a look at the inside. And then try to see the difference. So you see, I see a metal frame here, I see a metal frame here, I see my different filters and capacitors, I see my different filters and capacitors over here. So all the same. The only thing is the vacuum tubes are gone, and there are transistors over here. And they are mounted in the frame like they are mounted, like the vacuum tubes were mounted. And even if you look at the bottom, then you see that at the bottom side, so you see here the rubber with the transistor is soldered to the other components. There's not even a PCB in there. So what we see over here is a transistor technology based radio, but the whole architecture is a vacuum tube architecture. And you will be surprised if you look at it, how many circuits, even today, are transistor circuits, CMOS circuits, but the architecture is still a vacuum tube architecture. So people are still not making full use of what transistors can do and what you can do with 1 million transistors. This is a radio that has enough with 3 transistors, like this one has enough from 3 tubes, but it is not a transistor radio in the essence. And we want to prevent you from building vacuum tube architectures with modern technology. So that is what this course is about. So what we want to include in all this is the evaluation, the synthesis and the operationalization part. So we want you to do the full circle, as we call it. And what do I mean with this? Operationalization. That means that if you reached level 6 and you know how to do the synthesis, it doesn't mean that when you get a fresh problem, you immediately know what to do, how to start with it. And in this course, we will spend a lot of time in making sure that when you are at this level, you can actually make a design, which will be very convenient. For example, when you're going to do your bachelor end project and you have to build electronic circuits, then you're not talking about theory, but you have to design circuits, design PCBs, and create functionality. And and we will teach you how to do that. So what we want to do is let you go around the full circle, and you go around here only once. So the full circle is what you need. And when I talk to industry, and I quite often do, to big and small companies, what do you want of engineers that come from the TU Delft? They say we want them to have gone through the full circle, which means they shouldn't only be able to put a design together, but actually evaluate what they built based on measurements, and then able to know what they should be doing to get a next circuit, to do the invention. And that is the structured electronic design methodology that we want to teach to.